All right, so we found where basically both graphs are going to intersect will be a pair of numbers that satisfy both situations. Okay, so what we just did is solve a system of equations. And so this next unit that we're going to do, Unit 6, is on systems of equations. So let's write what a system of equations is. So a system of equations is, it feels like I'm using the wrong grammar, but that's definitely right. Two or more equations with the same two or more variables. Today, we're really just going to have two equations, and most of the time our two variables are going to be x and y. All right, so a solution to a system of two equations is an ordered pair and most of the time the ordered pair is xy. I guess it's possible we could have different variables, but that ordered pair that satisfies both equations. Alright, and there is sometimes a situation where there isn't an ordered pair that satisfies both equations. So like if it was a parabola and a line, like what we just had, you could have the parabola up here and the line down here, and they would never cross each other. There would never be anything that satisfies both. Or we could have two parallel lines that never have a point in common. And when that happens, the system is called inconsistent. So a system with no solutions is inconsistent. And you might remember most of this stuff from what you learned in Algebra 2. Alright, so on number 1, it tells us to use algebra, but actually I'm not going to. So I'm just going to solve this by graphing, but I'm going to do the graph without the calculator. Alright, so to graph, most of the time you need the equation solved for y. And so this first one, to solve it for y, I'm just going to add the x or move the x to the other side, but when you move it to the other side, it becomes positive. And then for the other one, to move the x squared to the other side, it becomes negative. I feel like maybe the very first unit we did this year was on lines, and it's been a while, but if we were going to graph this line, what is 5? What part of the line is 5? Do y'all remember? The y-intercepts. So on the y-axis, we would have a point at 5. All right, and then what's the slope? 1. So for a slope of 1, it's 1 over 1, so we go up 1, right 1, up 1, right 1. Now we really want to get as many perfect points as possible if we're going to solve by graphing. So instead of going up right, we can also go down left. So down 1, left 1. So I'm just going to do that all the way to the edge of the graph. All right, and then for the parabola, so the quadratic parent function is up on the wall. And so what would this negative do to it? It's going to flip it upside down. So the parent function looks like this. Whenever we have that negative, it reflects it over the x-axis, so it's like this. And then what about the plus 7?
That's y.
The y-intercept is 7. It's going to move it up 7. So I would have 7 is right there, I'm pretty sure, yeah. Alright, and then one thing about parabola is it is symmetric. So if I wanted to find a point, like here, whatever value I get for 1, I'm also going to get that value for negative 1. And so if I put in 1 and square it, I get 1. And then negative would make it negative 1. And then plus 7 is going to be 6. So we have those 2 points. All right, and then we can plug in 2. So 2 squared is 4, make it negative, and then add 7 to it, it's going to be 3. All right. And then that's going to, as soon as you get where all the places where it would intersect, then you can stop plugging in numbers and then just go ahead and draw the parabola. Okay, so this one has 2 solutions. One is at negative 2, 3, and the other is at 1, 6. All right, and then on number 2, we were going to use the calculator kind of to do. I'm going to graph it without the calculator, but we need to use the calculator to find the solution. All right, so to solve this first one for y, we're just going to move natural log over by adding it to the other side, and then we would subtract the x. Okay, so y equals natural log of x is actually the parent function we have on the wall for logarithms. One exact point that I know is on that graph is the point 1, 0. And then there's going to be a vertical asymptote. It's going to curve kind of like that. All right, and then the other graph is a line with a y-intercept of 2 and a slope of negative 1. So we don't know by this graph without the calculator what that intersection point is. We can guess, like it's about 1.5 to the right and then about half up, but we can use our calculator to actually find it. All right, so get your calculators out, and then for y1, we're going to put in the natural log of x. And then for y2, we're going to do negative x plus 2. All right, and so that looks a lot like the graph I drew. This isn't a square window, so the slope doesn't look exactly like it's negative 1. It looks a little flatter, but that's okay. All right, so we want to find where these intersect. In my last class, when I asked them how you do that, they said to look at the table. And the table is great if they intersect at a whole number or an integer. But this one, if we look, it's going to cross at a decimal. We don't have an exact value, so we can't use the calculator. We can't use the table. So instead, we're going to do second trace and find the intersection, which is number 5. I'm going to write these steps down in just a second if you don't remember. So second trace and then number 5. And then right now, you don't see the flashing cursor because it's off the graph. So if you start hitting right a few times, you'll see there it is, the little cursor. And so we're going to move close to where they do intersect, and then just hit enter 3 times. And there it is. And then we'll just round to a few decimal places. said about 1.5 and then about a half going up. So we were pretty close at our guess. All right, so I'm gonna write the steps down if you need them. Okay, and then the next question, we're going to see what we can figure out. We're not going to use a graph at all on this one. All right, so for number 3, Mrs. Skipper starts a t-shirt company with Miss Stewart. The startup cost was $1,200 for equipment and supplies. It costs them $5.50 to make each shirt, and they will charge $9 per shirt. And so A wants us to write an equation to represent the cost of producing X t-shirts. So I'm going to call it C for cost. So what do you guys think?
Y equals
5.5x. Does anything else cost? The startup of $1,200. So that's the cost for X shirts. So the $1,200 that they just need to spend at the beginning, and then how much it costs for each shirt. Good. All right, and then for B, write an equation to represent the revenue. So how much money we're going to bring in for producing and selling X t-shirts. How much are we going to charge them? 9. So it's going to just be 9x. $9 for every shirt we sell is that's how much revenue we'll bring in. All right, and then C wants us to figure out how many shirts we need to sell to break even. So if we're going to break even, then the cost should equal the revenue, right? So what we'll do, we'll just set I'm going to do the revenue on the left. It doesn't matter because it's the equal sign. I'm going to set my revenue equal to my cost. And then just solve it for x. So we'll subtract the 5.5x from 9x. And then divide. All right, and we don't get a whole shirt. So we obviously need to round up to a whole shirt. So 343 shirts to break even. That's a lot of shirts. I think we probably need to charge more than $9. All right, so after we break even, then anything after that is just straight profit. And so the second part of this question is how many shirts do we need to sell to make a profit of $150? So how much, after we break even, how much profit are we making per shirt? After it, yeah. 350, right? Yeah. So 350 times the number of shirts. We want to know when that will equal $150. And so we will just take 150 and divide it by 3.5 and we get 42.8. So we need 43 more shirts. So 386 shirts to make $150. Don't think this is a worthwhile business that we started. All right, any questions on that? Okay. All right, for number 4, we're going to consider a linear system where the first equation is 2x minus 4y equals 5. The system is inconsistent, and so we're going to write a second equation. There's an infinite number of these, This is a line, so we could do a line and a parabola that would either be completely above it or below it. The easiest thing to do is to do two parallel lines. And so if we want to do two parallel lines, the quickest way is for this to be the same, 2x minus 4y. And then it needs to equal any other number except 5. Do you guys have a favorite number? It's your chance. Any other number? 500? Is that what you said?
I said 100.
100. I just figured someone would say 6, 7. Like, why? It's crazy. All right, so it could equal any number other than 5. So that is the same, and then these are different, and that's going to be parallel lines, and it would make an inconsistent system. So you could get extra creative and figure out what that line looks like and do a parabola if you wanted to, or you could just make it easy on yourself. All right, and then number 5, we want to write a system of equations that has -3/8 as a solution. All right, so we need to do something to x and y, anything you want, mathematically, to x and y. You want to add x and y? Add x and y, okay. So if I added this x and this y, what should it equal? 5, right? -3 plus 8 is 5. All right, so that's one equation that -3/8 is the solution, and then we just need a different one. What else do you want to do with x and y? Square x. And then what would we do with y? Add it? Okay, that's weird. That's exactly what I made up when I did this before. All right, so when I square x, it's 9. And then when I add 8 to that, that's going to be 17. So that's my system. So when you guys do this on your own, you should probably not make up the same one as me. It would be, you can do anything you want to with x and y though.